So when we talk about numbers, we break them up into two categories. Numbers either fall under the real numbers category or they fall under the non-real numbers category. A non-real number is like the square root of negative 16. And we've talked about this. There's no number that when you multiply it by itself gives you negative 16. Real numbers are basically every other type of number. Real numbers are then broken down into even more specific groups called rational numbers and irrational numbers. Rational numbers, remember, has the base word ratio, which tells me that any rational number can be written as a fraction. So a number like 3.2 would be considered a rational number because I could write that as 3 2/10 as a fraction. A number like 3/8 is a rational number because I can write it as a fraction. A number like 0.3 repeating is rational because I could write it as the fraction 1/3. A number like 8 is rational because I can write it as a fraction 8/1. So the test to see if something's rational is ask yourself, can you write this number as a fraction? A number is classified as irrational, that keyword ir meaning not, if you cannot write it as a ratio. So one of the most popular irrational numbers is pi. You're going to notice with irrational numbers that they have decimals that go on forever and do not have a pattern, a repeating pattern. So to compare that to 0.3 repeating, 0.3 repeating goes on forever, but it follows a pattern. And you know that 0.3 repeating is a fraction, and that fraction is 1/3. Another irrational number, or another test to see if a number is irrational, is it a perfect square? So if you were to take the square root of 17, that's not a perfect square, and so anytime you take the square root of a number that's not a perfect square, you get this decimal that goes on forever and ever and ever and doesn't repeat. So any number that's not a perfect square would be considered an irrational number. Also, a number that's not a perfect cube, if you were to take the cube root of that, you're going to get an irrational number because you're going to get that non-repeating decimal. If we head back into the rational numbers, we categorize them into even more specific groups. The first group we make is integers. Those are basically whole numbers that are positive and negative. So you're going to notice that integers do not have a fractional part. So yes, they can be written as fractions. So like 2 is 4/2. 4/2 is an integer, but you're going to notice that a number like 3.2 is not an integer because it has that decimal or fractional part. Whole numbers get a little bit more specific. Whole numbers start at 0 and count up by ones. Natural numbers are basically the whole number set, except they do not include 0. So natural numbers start at 1 and head up by ones. What you notice is that in the rational numbers, the groups get more and more specific. So as we got to the natural numbers, we got more and more specific. A number that is a natural number is also a whole number. It's also an integer and a rational number. So if you're on the inner level of this structure, you are part of all the other structures above it. So the bottom of your homework asks you to sort numbers and by placing the corresponding letter in the appropriate box. So let's start with -100. If I read the boxes from left to right, the first box asks for a real number but not a rational number. That's basically asking for an irrational number. The next box wants a rational number that's not an integer, so that's going to be a number that has a fractional part. The next box is looking for an integer but not a whole number. That's where I'm going to put -100 because -100 is not considered a whole number because whole numbers are always positive. But -100 doesn't have a fractional part, so it belongs most appropriately an integer but not a whole number. 4.2 is a rational number because it can be written as a fraction. It would be written as 4 2/10 if I wanted to write it as a fraction. So the box that best belongs in is a rational number but not an integer, because integers can have decimals or fractions in them. Negative square root of 121. Well, I do know what the square root of 121 is. The square root of 121 is 11. So the negative square root of 121 is really the same as negative 11, which is an integer. So I'll put it in the third box. The square root of 18. 18 is a non-perfect square, so when I take its square root, it's going to be a number whose decimal goes on forever without a pattern. So that's, by definition, an irrational number. Negative 34 over 2 is a fraction that can be reduced to a whole number, which is negative 17. Negative 17 is an integer, so negative 34 over 2 also belongs in the third box. The last one is this crazy looking decimal. The fact that it has dots at the end of the number tells me that it continues to go on forever. I don't know it as a pattern, so I know that this is going to belong in the irrational category.